Let's look at some examples of adding and subtracting with integers, positive and negative numbers. So in our first example here, if we are just using the rules that we learned, remember that if the signs are the same, the sign stays the same. So since I have two negatives that I'm adding, I know that my answer has to be negative. And if I have 7 negatives plus 3 negatives, I'm going to end up with negative 10 as my final answer. Here are some other examples of ways that we can visualize this. So with the number line method, I start at -7 facing the positive direction. Then, because I see the negative in front of the 3, I face in the negative direction and move 3 spaces, landing on -10. Another way of thinking about it is if we have our negative and positive counters, I start out with 7 negative counters, and then I'm adding 3 more negative counters, and so when I total it up, I have 10 negative counters in total. Here's another example. So I have 6 subtract -2. Now remember, anytime we see a subtraction problem, we want to change it to an addition problem using keep, change, change. So I'm going to keep the sign of the first number, -6. I'm going to change the operation, and I am going to change the sign of the second number. So keep, change, change. This now becomes 6 plus +2, or 6 plus 2. So I end up with 8 as my answer for this problem. So you can also see the number line method. I start at +6 facing positive. I flip once because of the subtract. I flip again because of the negative. I move forward 2 spaces and land on the 8. With our 2-color counters, we start out with +6, and I want to take away 2 negatives, but I don't have 2 negatives to start out with. But what I can do is add in these 2 pairs of 0, because remember, a positive and a negative eventually cancel out to make 0. So all I'm doing is adding 0 in the form of these counters, and then I am going to subtract or take away these 2 negatives. And what happens is then I'm left over with 6 plus 2 is 8, 8 total positives. So there's another way to visualize why this is the correct answer. Let's take a look at this other problem here. So I have -5 plus 2. Remember that if I have different signs, I'm first going to compare the 2 numbers, 5 and 2. 5 is bigger, so that means that negative is going to be the sign for my answer. Okay, so whichever number is bigger will give me the sign for my answer. Okay, then remember that I have the negatives and the positives, they go to battle. I have 2 cancel out from each side, so I'm left with 3 negatives. So one thing that you can think about is I'm taking the difference between 5 and 2, so 5 minus 2 is 3, and then I just want to make sure that I have the correct sign, and it's whichever one was bigger. Here's my number line evidence. I started at -5 facing the positive, and I move forward 2 spaces, and I land at -3. With my 2-color counters, I started out with 5 negatives, I added 2 positives, and remember, we can cancel out pairs of positives and negatives. So I had 2 0 pairs that I was able to cancel out, leaving 3 negatives behind. Okay, let's do one more example. So this is another subtraction problem, so I want to use keep, change, change. Okay, one thing to be careful about is remember this is 2 subtract 8, a +8. So there's that imaginary positive sign there. So I'm going to keep the sign of the first number, change the operation to positive, change the sign to negative. So now I have 2 plus -8. Okay, so comparing positives and negatives, I have way more negatives, so my sign is going to be negative. The difference between 2 and 8 is 6, so -6 is my answer. With the number line, I start at +2 facing the positive direction. The subtract sign tells me to flip to the negative direction. I move forward 8 spaces and I end up at -6. With my 2 color counters, I have +2, I have 8 negatives, I cancel out 2 of the 0 pairs, and I have 6 negatives left over. Now I'm going to do some examples of story problems. This first problem here is the one we're most likely to get confused on and make mistakes on. I'm going to show you first algebraically, meaning I'm going to make a number sentence that represents or models this problem that we can solve using the rules we just practiced. Then I'm going to show you the picture or conceptual method that also works really well for these problems. So we begin a hike in Death Valley, California at the elevation of -86 meters. Then we hike to an elevation of 45 meters. What is your change in elevation? Now change is one of those key words that can mean difference or distance between the two elevations, which indicates that we're going to use the operation of subtraction. Okay? And when I'm taking a difference or a distance, I always want to go biggest number, subtract littlest number, okay? So I'm going to start with +45, and I'm going to subtract -86, and that is one of the first places that we could go wrong. It needs to be subtract, and it needs to be -86. Okay, so this is the number sentence that models this problem. Then, because it's a subtraction problem, I'm going to use keep, change, change to change this to an addition problem. So, I keep the 45, I change the subtract, I change the negative. This is equivalent to the number sentence 45 plus 86, which equals 131 meters. Now, the second method is more of a conceptual method, but it helps to illustrate why this is true. So I'm going to draw a picture. Here is 0 elevation, often referred to as sea level, so 0. We have -86, which is our starting point, and then above it, 45 meters above sea level, is our ending point. And we want to figure out the change in elevation, or how many meters total we are traveling. Well, it takes 86 meters to travel from -86 to 0, plus 45 meters to travel from 0 to 45. Okay, so 45 plus 86 is our final answer. It's important to note that we're not subtracting, we're adding those two distances. So subtracting a negative is the same as addition, but we don't want to subtract a positive. So for example, a lot of people might do 45 subtract 86 or 86 subtract 45, and neither of those will produce the correct answer. This one's a tricky one, so make sure you rewatch if you need to make sure it makes sense. All right, let's read our next problem. You are playing a board game, and you draw a card that tells you to move backwards 5 spaces. On your next turn, you get to move forward 2 spaces. How did your position change after both moves? Okay, so I want to find out what happens after the 2 moves. So I'm going to make a visual representation here. So here's my starting position. And I know that I move backwards 1, 2, 3, 4, 5 spaces. Okay, so I move backwards 5 spaces. And then I move forward 2 spaces. So, how did my position change after both moves? I am back 3 spaces. or -3. So that's the change in my position. Okay, now let's take a look at the number sentence. I have 5 that's negative spaces plus 2 spaces. And I can use my rules. So I have 5 negatives, 2 positives. 2 are going to cancel out from each pair, and I'm going to be left with -3. Now, this is different from the previous example where we subtracted a negative or added the values together. It's not asking how far did I travel total. That would be 2 subtract -5 or 7 total spaces. It's asking me how did my position change after both moves. And the answer to that question is at the end of that, I moved backwards a total of 3 spaces compared to my starting position. So you want to make sure that you're really making sense of the problem before you jump into a solution method.